Hi and welcome! In this video we're going to restore and repair the Creative Sound Blaster CT3930. This is a relatively rare ISA sound card of the SB32 family. It is based on the Vibra 16 CT2501 chip and has both a Yamaha OPL3 chip for FM synthesis and an EMU8K for AWE32 wavetable synthesis. Just like the AWE32 cards, it has two SIM slots for additional sound font RAM for a maximum of 28 MB sound font files. When I first got the card, it was very filthy, smelly, corroded, and a bit disgusting. I got the card on eBay along with several other cards, all of which were equally filthy and corroded. Well, at least they were not damaged during shipping. The box they came in was so disgusting that I immediately washed up all the cards with soap and water and threw away the box. Even after cleaning the card thoroughly, there was still a lot of gunk and corrosion on the chip pins, so I scrubbed them a lot with some brushes, perhaps more than I should have. They didn't clean up very well though, but the card definitely looks better than before. While scrubbing the pins, I accidentally ripped off one of the two bodge wires connected to the EMU8K chip. I will try to fix this later in the video. Okay, let's try to see what works and what doesn't. Well, the good news is that the card gets initialized by Unisound just fine. Let's try some games. First, let's configure it as a standard Sound Blaster card.
Your sound card works perfectly.
Digital sound seems to work fine. FM music also works. Great! Now let's configure it as an AWE32 card. And it's broken. So let's try to fix the bodge wire that I had accidentally ripped off while cleaning the board. As far as I can tell by looking at some earlier footage, the bodge wire was connected on one side to the corner pin and on the other side to ground through an SMD capacitor. I'm not sure what capacitance value I need, but I would guess that both bodge wires were using the same value. So let's disconnect the good bodge wire to measure the capacitor off circuit. It's 220 picofarads. Now that we got the capacitor's value, let's reconnect the wire. This is really fiddly and I'm clearly not doing a great job. Yeah, I messed it up, but it will do for now. I will fix it properly later. For now, let's replace the bodge wire with a through-hole capacitor, as it is much easier to work with. Okay, let's plug in the card and try again. Sadly, this didn't fix the issue. I'm still getting white noise. Perhaps some of the electrolytic capacitors are damaged or have dried up and are the cause of this noise. This capacitor looks quite suspicious. I am using the TC1 tester to check their values. I don't think this is super accurate when measured in circuit, but I will try to replace the capacitor if it looks damaged and if it also shows a strange reading. Let's remove it. And yeah, this capacitor is clearly bad. I'm replacing it with a new one. Sadly, this did not fix the issue either. I'm still getting the white noise. Perhaps the EMU8K chip needs reflowing. It looks okay, but let me try to go over the pins one by one with the soldering iron just in case. Well, as expected, this didn't fix the issue either. Upon closer inspection, the Vibra chip seems to have a couple of pins that need reflowing. This may be the reason for the noise, but it may also be the reason why the card was not always being reliably detected on system startup. Let's try to reflow the pins. Now let's try to see if this fixed the issue. And yeah, we're getting AWE32 audio without any noise. I think though there is something off. Perhaps some instruments are missing? Well, anyway, since we fixed the main issue of the card, let's try to fix the bodge wire properly with an SMD capacitor. So now we're done, right? Not so fast. It turns out that the issue with the noise is intermittent. It seems to be coming back at random after a power cycle. Well, this kind of behavior sounds like a capacitor issue, so let me check all capacitors one by one. These ones show some strange values, so let's replace them. I tested each capacitor that I removed, and it turns out the first one had a capacitance thousands of times less than what it was supposed to. The second one had a very high ESR value of 74 ohms, and the third one was just bad. Let's boot the system and try out the Sound Blaster diagnostic just in case we get any more clues. This high-pitched noise we are hearing is occasionally generated by the card, but seems to go away with a second initialization. We just click through the menus until we get to the audio test options.
Testing. 8-bit testing.
Digital audio works just as expected, and the left and right channels both work correctly, but you can't tell them apart because I captured the audio in mono. FM sound also works. And we're still getting the same noise even in the diagnostic. Okay, now that we have fixed some of the usual culprits, like dry joints and bad capacitors, it is time to do some proper investigation. Let's take a look at how the card works. The main chip of the card is the Vibra 16 CT2501, which is also responsible for the Sound Blaster digital audio. Then there is the Yamaha YMF262 OPL chip along with its DAC chip, the YAC512, which are responsible for the FM MIDI music. Finally, there is the EMU8K chip along with its DAC, the Philips TDA1387 chip, which are responsible for the AWE32 music. Okay, so the noise may be coming from a bad Philips DAC chip. Or perhaps the power circuit that powers the DAC is noisy, causing it to generate noise on the output. The DAC's power input pin is connected to this capacitor, which does not measure quite right. So let's replace it to be on the safe side. Well, it has a pretty high ESR value of 43 ohms. Well, this didn't fix the issue. So let's try to replace the DAC chip itself with one from another Sound Blaster card that works fine. Let's remove the chip from the broken card and replace it with a good one. And let's try the audio test once again. Well, we're getting some O32 music, but we're also getting noise. This is very strange. Perhaps this new DAC generates a louder output? Could the amplifier circuit after the DAC be generating all this noise? Let's look at the circuit. The audio signal from the DAC gets amplified by the 3403 op-amp. Let's solder a wire directly onto the output pin of the op-amp to check if the noise is generated there or if there is some other component after it that is introducing the noise. And yeah, the output of the 3403 is noisy. So this must be the broken part that is messing up the DAC's output. Let's replace it with an LM324 which is pin compatible. And still getting the same noisy output. This is very strange. Could the output of the DAC be noisy? Well, the DAC's audio output is very weak, so I can't check it without attaching an amplifier circuit which I don't have available. But given that we replaced the op-amp and we're still getting the same issue, we must conclude that the DAC's output must be noisy in the first place. And this can only happen if the EMU8K is generating noisy digital audio. But how can you get noisy digital audio? Is it even possible? The only way this can happen is if either the sample ROM or the RAM is faulty. The EMU8K is connected to the EMU811 sample ROM chip and a 64K by 4-bit RAM chip. Let's remove the RAM and check the audio output. And yeah, we're getting the exact same noisy output. Okay, so the RAM chip must be bad or at least not working reliably. But I don't have a replacement RAM chip in this DIP18 package, but luckily the PCB has pads for an SOJ package, so I could use a chip from a SIM memory module. And by the way, the O64 card seems to have an SOJ RAM chip, not a DIP one. Let's try to clean the pads and add some fresh solder because they look quite corroded. This RAM chip from a 1MB module should do. It is 1 meg by 4 bits. Let's desolder it. I have set the temperature at 280 degrees and the airflow at about half. Now let's solder the chip onto the card using hot air. Some pins were not soldered correctly, so I had to solder them with the soldering iron off camera. Let's check the audio output. And yes, finally we're getting proper audio. And this time the music sounds really nice. Let's try out the Sound Blaster diagnostic software once again.
8-bit testing. 8-bit testing. 16-bit testing. 16-bit testing.
Yeah, it works great. Now that the wavetable audio works, let's add a couple of memory modules to the DRAM slots. The external DRAM is not being detected. Well, the SIM slot contact pins are probably corroded, so let me try to clean them a bit by going over them very gently with a small file. This made absolutely no difference. I also tried some contact cleaner, but that didn't help either. Okay, there must be something wrong with the circuit, so let's take a closer look. The DRAM slots are connected to the EMU8K chip via these 74F244 octal buffers. These are used to boost the address lines A0 to A11 and also the RAS and CAS and WE signals. Each output of the octal buffer goes through a 33 ohm resistor which is in these 4 resistor arrays. Finally, the data lines of the top and bottom SIM slots are connected directly to the EMU8K chip. What's interesting is that the write enable signal is not going from the EMU8K directly to the buffer. Instead, it first goes through a 7405 inverter, then through some LS27 NOR gates, and then it finally connects to the buffer input. The write enable pin at the memory module, pin 21, seems to be the only one that does not show any activity. And if we check the write enable pin at the EMU8K chip, pin 4, we can clearly see some activity there. So there must be something wrong either in the inverter or in the NOR gates. Let's check the pins with the oscilloscope. The input pin shows some activity, but the output pin shows no activity. So this inverter chip must be faulty. I could not get a replacement 74LS05 at my local electronics store, so I got instead a 74ALS05, which I think should be compatible. Let's desolder the faulty chip. I'm trying to align the new chip correctly, but it's a little bit tricky. This looks okay, so I will solder 2 pins first so that the chip can't move, and work on the rest of them one by one. Well, it's not pretty, but it will do for now. Now let's power on the computer and check the signal at the input and output pins of the inverter. And yeah, the output is now showing some activity, even though the voltage is quite low, which is strange. And will you look at that? Unisound detects the DRAM correctly. We have 2 MB of DRAM. Let's try out the Sound Blaster diagnostics once again. Now that it detects the external DRAM, it runs some RAM diagnostic tests. And yeah, the DRAM works great. Now let's try out OUtil. It should be showing more options now that we have the extra memory. And indeed, it is showing the options for GS and MT32 emulation. Awesome! Let's try it out. It is complaining about the initialization of MPU401. According to the card's manual, for this to work we need to set the MF bend jumper, which is the one next to the chip that we just replaced, and it is already in the correct position. As far as I can tell, this jumper allows the main chip of the card to connect to the I/O channel check pin of the ISA bus, which is for triggering a non-maskable interrupt. After a brief search online, I think that some motherboards may mask it, but I may be wrong, so I'm not sure this particular motherboard can work with it. If anyone knows how to resolve this issue, please feel free to let me know in the comments below. Anyway, this video has become really long, so I will just stop here. I really enjoyed restoring and repairing this card, and I'm looking forward to trying out all its features. I hope you enjoyed watching this video as much as I did investigating the faults and fixing them. Oh, and by the way, here is part of the pinout of the EMU8K chip that I figured out by following the traces on the board. I could not find any datasheets for any of the creative chips, so this may be useful for some of you who may be trying to repair similar sound cards. And as always, thanks for watching and goodbye.